Hi, my name is Daniel Gottschall. I'm with the Mathematics Learning Resource Center here at Villanova, and this is my second video on scaling functions vertically. Specifically in this video, we'll talk about compressing functions. So what do I mean by that? Well, basically compressing functions vertically means that we're shrinking the function, so to speak. So we would have something going on like this, and this. So basically, I'm pulling in this case, I have the y equals sine x function as an example. I'm pulling the humps inward towards the x-axis. So I'm shrinking the vertical dimensions of the function. All right, and let's say, for example, that I want to shrink it by a factor of 2, or in other words, I want to cut the vertical height of the function in half. And I claim that the function y equals 1 half sine x does this for us. Let's see why that is. So let's check our points, just like we did in video 1. So when x is 0, sine x is 0, and so 1 half sine x must be 0, because 1 half times 0 is 0. Similarly, 1 half sine x, when x is pi over 2, I have 1 half times 1, which is a half. So I do have here, right, so at that point, pi over 2, it only has a height of 1 half. So I didn't quite draw this clearly. That should be pi over 2. Alright, and then when x is pi, sine x is 0, so 1 half sine x is 0. X is 3 pi over 2, sine x is negative 1. 1 half sine x is 1 half times negative 1, which is negative 1 half. So I land there roughly. And then when x is 2 pi, sine x is 0, so 1 half sine x, which again is 1 half times 0 is 0. So I have the function looking something like this on the right side of the y-axis, and sure enough, we see it looks just like how we wanted, that the hills are being pulled down, so to speak, or pulled towards the x-axis. I probably shouldn't say down, because like the second hill here is being pulled up, but I mean the heights of the hills are basically shrinking, whether they land on a positive y coordinate or negative y coordinate. Alright, then for an exercise in this video, I would recommend trying the same thing for these 4 points I drew, so negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. You could try it again with just sine x if you want to verify what I'm saying, but definitely try for the green function, y equals 1 half sine x. So pause the video and think about that. Alright, welcome back. Hopefully you got this. Just going to pull it over here so we can look at it. There. Alright, so we see from where the 4 points are. So at negative pi over 2, I have negative 1 half. 0 and 0. 1 half here and 0. So we see on the left side the y-axis. Whoops. Let me draw that a little better. We see on the left side that looks something like that. And sure enough, so we see again that the hills on the left side of the y-axis are also shrinking in size. So that's the whole idea here of compressing functions vertically, that we're cutting their height in half, essentially. Alright, so now you've learned about, if you watch video 1, stretching functions vertically. This one's all about compressing functions vertically. So see video 3 for kind of where we think about these concepts more in general, seeing how they relate to each other, and even sort of a third idea that comes from that. Anyway, watch video 3 for details.